Welcome to part 1 of lesson 33 of our interactive notes. So we are going to be comparing fractions by comparing to benchmark fractions, pages 13 and 14. So here our content objective for 4th grade, NF, numbers, operations, fractions, A2. I can recognize that comparisons of fractions are valid only when the two fractions refer to the same whole. That goes to that candy bars that we looked at in the last lesson. I can compare fractions using symbols and justify the comparison by using models. Language objective. I can use vocabulary related to fractions to communicate how to compare fractions. Social objective. I can work with others to create models to prove the comparison of fractions. So we're looking at benchmark fractions. Well, what are benchmark fractions? A fraction by which something can be measured or judged. Fractions can be compared by using a benchmark fraction on a number line or fraction model. So if you know things like 1/3, 1/2, 1/4, if you're able to visualize those are ones you want to use. So ones like 1/2, 1/3, 1/4 are good ones. We're going to mainly focus on half first. If we can get down what half looks like, then that can help you as you build up your understanding of the other fractions. So this is the main benchmark fraction we're going to look at. Okay, remember a benchmark fraction is a common fraction such as 1/2 that is used to compare other fractions. Hint, the larger the digit in the denominator, the smaller the equal parts of the whole will be, because you have to cut it up into more and more pieces. So I want to find the equivalent fractions to 1/2. Well, 7 is half of 14. So 7/14 is 1/2. Half of 4 is 2. 2/4 is equal to 1/2. Half of 10 is 5. 5/10 is equal to 1/2. Being able to recognize these halves will be helpful. 5 is half of 10, 7 is half of 14, 2 is half of 4, 4 is half of 8. Something is half of 20. Well, 10 is half of 20. Something is half of 6. Well, 3 is half of 6. Getting to recognize your halves, your equivalent fractions that are equivalent to half, will be very helpful. Because we want to be able to use half as a benchmark. We want to compare 1/2, 4/6, and 2/8. Well, let's identify where all the halves are. So we have 1/2 here, 3/6 is a half, 4/8 is a half. Well, 4/6 is greater than a half. 2/8 is less than a half. So that means that if we were comparing, that means 1/2 is less than 4/6. Because it's greater than that half of 3/6. 1/2 is greater than 2/8 because 2/8 is less than 4/8, that benchmark 1/2. And since this is greater than a half and this is less than a half, that means 4/6 has to be greater than 2/8. So we're using just that reasoning without having to do any multiplying. If we know what a half is, half of 6 is 3. Well, 4 is greater than 3, so 4/6 is greater than a half. 4 is half of 8. Well, 2 is less than 4, so 2/8 is less than half. And if this is greater than a half and this is less than a half, then this has to be greater than this one. Okay, so now in these numbers down here, we just want to get down a bunch of fractions that we can say are close to these benchmarks. What fractions are close to being 1, or the whole thing being filled in? Well, an example would be 9/10. That just needs one more piece filled in for the whole thing to be full. Or 6/7 needs just one more. It is almost the whole thing filled in. 11/12. One more piece. So if you're just one piece away, it's pretty close to the whole thing being filled in. It's close to 1, especially as the denominator is larger. 8/9. One piece filled in. That's all we need. But as we have these larger denominators, sometimes being 2 pieces away, this only has 2 more pieces to fill in. That 10/12 is much closer to the whole thing being filled in than half of it, because half would be 6/12. So this is closer to being the whole thing filled in than just half. Similar to like 8/10. That's much closer to the whole thing being filled in than half of it. So if you see just one piece missing, it's closer to being a 1. So we can say it's almost, the whole thing's almost filled in. It's almost a 1. Those that are close to a half. Well, we know some of our halves, like 7/14, 5/10. But what if they're very close? Like, well, we know 4/8 is exactly half. But then would 5/8 be close to a half? Yeah, that's pretty close to a half. Or 3/8. Yes, that's very close to half if we're comparing. Half we went exactly, but what would be close? So like 5/10 is exactly half. So 4/10 is pretty close to half. And 6/10 is pretty close to half. You can't do half of 5. It would be 2.5. But say like 3/5 is close to a half. If we were to do something like the 10/20, that is exactly half. So 9/20 is pretty close to a half. And so is 11/20 pretty close to a half. 8/16 is exactly half. So 9/16 is pretty close to half. Or 7/16 is pretty close to a half. So it's getting it just close to that halfway mark. Now when it's odd, you can't find exactly half. Like 4/7 is pretty close to half of 7. But you're not going to get exactly half of 7 because it's odd. Or 5/9, something like that. Now close to 0, well, that would be more along the line of like your unit fractions, 1/4 or 1/10 or 1/5. One seventh, especially as you get your denominator to be larger, 1/12. But as the denominator gets even larger, You could even say something like 3/20ths, because those pieces are so small. This is much closer to being 0 than it is to being half, that 10/20ths. So that's closer to being 0. Or say something like 6/30ths, because the pieces are so small, it's closer to almost being nothing than it is to being half or 1. Even like 2/9 or 2/8. Each of these, because those pieces are getting smaller, are much closer to being 0 than they are to being half. So here we're going to use our logic and reasoning to compare fractions. And we're not going to even use any multiplying. So let's go ahead and go on to part 2 and practice comparing with benchmark fractions.